Okay, so in order to figure out the area of this box, we need to figure out its height and we need to figure out its width. Well, if we look at starting at this point, which we know we're saying that the x value of that point is x. Well, the x value of this point here is also x, and we just need to figure out its y value. Well, it lies on this line that has equation. Let's look here. We see it has a slope of 2 over 5. And it also has, it passes through the origin. So it's the equation for this line is y is equal to 2 over 5x. So we know, therefore, that the y-coordinate of this point is 2 over 5x, which means that this segment has length of 2 over 5x, which means that we have our height in terms of x, 2 over 5x. All right, now to figure out the width of the box, we need this x-coordinate, which means if we get this x-coordinate, we can determine it. Well, this point has the same y-coordinate as our point over here. So it has the y-coordinate of 2/5 x. Well, we also know that it lies on this line, and this line has an equation of, let's see, we have a slope of -1, and negative x is going to have a y-intercept of +7. So it's going to have an equation of -x plus 7. So if, let's say we call this point, the x-coordinate is x2, we know that 2/5 x, which is the y value of this point here, is equal to -x2 plus 7. We just plugged in x2, which we said is the x-coordinate of this point here, and we plugged that into our equation for this line, and we got 2/5 x equals -x2 over 7. And what that means is that if we rearrange this, we're going to get that x sub 2 is equal to 7 minus 2 over 5x. So now we know that this point has coordinates 7 minus 2/5 x, but to figure out the width of this box here, we need to subtract that x-coordinate. We need to subtract the x-coordinate of our point E, which is x, from the x-coordinate of this point here. So we get 7 minus 2 over 5x minus another x, which is going to give us 7 minus, so x is equal to 5/5 x, so we get 7 minus 7 over 5x. So that is equal to our width, 7 minus 7 over 5x. Our area, therefore, has to be equal to the product of those two, which gives us 2 over 5x times 7 minus 7 over 5x, which when simplified gives us 14 over 5x minus 14 over 25x squared. And that is our area. Okay, let's look at the next problem. We want to solve for x here. So again, fraction, we want to clear it, so we're going to multiply both sides by x plus 2. So on the left side, we're going to get 2 minus x. On the right side, we're going to get the product of these two, which is x squared, plus 4x plus 2x is equal to 6x plus 8. Okay, now we want to set this side equal to 0, so we'll subtract 2 minus x from both sides, which will give us x squared. This is now, we're going to end up adding x to both sides, get 7x. And we subtract 2, we're going to get plus 6. This is factorable because we have a number 6 that if we find two numbers that multiply to 6 and add to 7, we can factor. We're going to get 0 is equal to x plus 6 times x plus 1, which means that our two solutions are x is equal to -1, x is equal to -6. Okay, let's look at this next factoring problem here. So one of the things we'll notice if we, and this is for matter of convenience, you don't have to do this, but I find it makes it clear sometimes. X minus 2 is equal to a, so that gives us a squared minus 4 times -a plus 4 is equal to 0, which gives us a squared, plus 4a plus 4 is equal to 0, which factors to a minus or plus 2 squared is equal to 0. So that'll give us solutions of a is equal to negative 2. Well, we can replace a with x minus 2, which we're saying is equal to negative 2, which gives us that x would be equal to 0. That's the solution for our equation. Okay. All right, now we want to find out what values of a will make each of these a perfect square trinomial. So down here, we're going to get this should be y squared. So we know that we're going to have 3 as our, because we want the square root of that. We know that this thing right here is double the product of 3 and our the square root of this term here. So if we take half of negative 24xy, we get negative 12xy, which means that when we divide it by 3, we get negative 4xy. Or in other words, when this thing is squared, we're going to get 16x squared y squared minus 24, and let's get this out of the way, minus 24 xy plus 9, and that's going to give us a perfect square trinomial that factors to 4xy plus 3 squared. Okay, over here, let's take a look at this. We have a showing up in 2 places. So we know that this is going to end up, we know we're going to end up here with plus 4. And the question is, what are we going to have in the beginning here? Well, we know that 5a has to be a perfect square. So either a is itself a perfect square or a has to be equal to 5. We also know that 8a is equal to double the product of 16, or the square root of 16, and the square root of this term here. So we take half of 8a, which is 4a, and that's going to be equal to 4 times whatever the square root of this thing is here, which means that when we divide both sides, that a is going to have to be equal to 5. So we're going to get that 5a plus 4 squared is our factored version of this, and 25a squared plus, in this case, plus 16 plus 4 times 5a doubled is 40a. Okay, so a ends up having to be 5. So 8 times 5 gives us 40, and 5 times 5 gives us 25. All right. So that's done. So let's start factoring here. Okay, so we have AC plus 2B minus A minus 2BC. Well, that arrangement doesn't work. So let's rearrange it to AC minus A plus 2B minus 2BC. And now factoring by grouping, we're going to get A times C minus 1 plus B, or 2b, times 1 minus c. And when we reverse that, we're going to get a times c minus 1 minus 2b times c minus 1, which is going to lead finally to a factorization of a minus 2b times c minus 1. Okay, next factorization, we have 4x cubed minus 12x squared minus 9x plus 27. 4 terms. It's not a perfect square trinomial. We don't see one in there, so we're going to factor by grouping, which is going to give us, pulling out of the first 2 terms, we're going to pull out 4x squared, which is going to leave us x minus 3. And minus, we're going to pull out a 9, and that's going to leave us x minus 3 here as well. And that's going to give us 4x squared minus 9 times x minus 3. But this first term here is a difference of perfect squares, so we factor that to get 2x minus 3 times 2x plus 3 times x minus 3. Okay. Next one. Okay, we again have 4 terms, but here we have 2 terms with x and 1 with a y, and we do in fact have a perfect square trinomial of x squared minus 6x plus 9, and then minus y squared. So we're going to get x minus 3 squared minus y squared gives us difference of perfect squares. So we're going to factor 2x minus 3 minus y times x minus 3 plus y.